Welcome to the solution video of A and AS level Probability and Statistics 1, paper 53, 9709 is the exam. Question number 1. The 26 members of the local sports club include Mr. and Mrs. Khan and their son Abad. The club is holding a party to celebrate Abad's birthday, but there is only room for 20 people, maybe due to COVID. In how many ways can 20 people be chosen from 26 members of the club, given that Mr. and Mrs. Khan and Abad must be included? So we have to say sorry to 6 people. They can't be invited. All right. So we have to choose people, right? And person chosen first or 20th, they don't have any difference. They are just chosen for the party. There is no order. So we can use combination. Since the order is not important, combination is used. So how many will you see? How many candidates are there in total? 26, correct? But Mr. and Mrs. Khan and their son are already taken. They are part of the party already. So 3 places are taken. We are left with 17 more spaces, right? So we have to select 17 people out of how many? Again, out of 26, these 3 guys are out. So left are 23. So it will be 23C17. That will be the number of choices you have. And let me use my calculator to find this. By the time I do this, please subscribe to my channel. 87% of my viewers are not subscribed. If you like and share with your friends, that will motivate me to make more such videos. Thank you very much. And the answer I got was 100947. Let's move on to the next one. Lakeview and Riverside are 2 schools. The pupils at both schools took part in competition to see how far they could throw a ball, okay, like a shot put. The distances thrown to the nearest meter by 11 people from each school are shown there, okay, Lakeview, Riverside. All right, draw a back-to-back stem and leaf diagram to represent this information with Lakeview on the left, okay, so Lakeview on the left. I have already drawn the lines, and obviously Riverside will be on the right. Okay, so are they in increasing order? They are, so not a big deal. So we are starting with 10 for Lakeview. So 1, then we have 20s, 30s, and 140 also there. So we start from this corner, from the lowest one, and we increase our numbers towards the left if your particular data is on left. So 0, 10, that makes it 10, and then 14, then 19, then 22, 2 is here, so 2 will be here, 26, 27, 28, 30, 32, 33, and 41. Okay, similarly, we'll do for Riverside. And it is not in order. Wow. So that means I'll have to see 18 is the smallest one. 18, yes, so 8 has to be here. Then we have 20. Okay, so let's see if we missed anyone. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That means we missed one of them, and which could be 18s. Okay, we got them now. Draw back-to-back stem and leaf diagram with on the left side, done that, but it is incomplete without a key. So we should write a key here. Key, let's say 2, 2, 5. So represents 22 for the distance thrown by a lake view student, and 25 by a riverside student. So this completes our stem and leaf diagram. Let's see what the B part holds for us. Find the interquartile range IQR of the distances thrown by 11 people at Lakeview School. Okay, so for IQR, we need upper quartile Q3 minus lower quartile Q1. So to find Q3 and Q1, the plan is to find median first. So if this is the data, median will be the middle number if it is possible with odd numbers. If they are even, then we'll find the average of the two. Okay, and then we exclude the median and find the median of the lower data and median of the upper data. Lower data becomes Q1, upper data is Q3. Upper quartile, lower quartile, we just subtract that. That's the plan. So let's go back to the, let me do it here. Okay, so Lakeview, this is the data. Let me move it down a little. Yeah, that's the data. So how many are there? There are 11, odd, very good. When there are odd number of data, just add 1 and divide by 2. That means 11 plus 1 divided by 2, sixth item is the median. From bottom, so this is the smallest, 1, 2, 3, 4, 5, 6, 27 is the median. And we will exclude 27 from finding the Q1 and Q3. So now how many are below this? 1, 2, 3, 4, 5 are below this. They're again odd. So 5 plus 1 divided by 2. Third item will be the Q1. Okay, so this will give us Q1. Third, 1, 2, 3, 19. 19 is Q1. Let's find Q3 now. Again, third item, just they are also 5, right? 1, let's say 1, 2, 3, 4, 5. The 5 are here. So we can find the third one. So 28, 30, 32. 32 is the third from the lower side, and Q3 becomes 32. So 32 and 19 are Q3 and Q1 respectively, and our IQR becomes 32 minus 19, which is 13. That's interquartile range. Let's go to the next one. The times taken in minutes by 360 employees. So N is 360. They have already confirmed that. At a large company, the travel from home to work are summarized in the following table. Okay. Frequency is given here. Draw a histogram to represent the information. Okay. If you see, the difference between 0 and 5 is 5. So class width is 5 here. Next class width is again 5. Next 10 to 20 will be 10. Here it is again 10, and then it is 20. So we can see that the class width is inconsistent. It is variable. In such case, what do? We add a new row to it, which is called frequency density, so that they are fairly comparable. So 23 divided by 5, the frequency density of this particular column is 4.6. 102 divided by 5 will be 20.4. 135 divided by 10 is 13.5. This is 7.6, and 24 over 20 will be 1.2. So the data is most dense here. This should represent the highest column, and that's what we do when we draw the histogram in such cases. So we will do what? We will write time taken for commuting to office. Let's represent that by T. And this vertical axis will be the frequency density, not the frequency, because the class widths are not equal. So let me change the position of this so that I can write my scale here. All right. So let's write scale. So we have highest data is 50, I think. Yes, it is 50. We cannot change the scale according to the table. So we have to see that 50 comes here. Let's say 50, okay. 10, 20, 30, 40, 50. So 50 can come here. 40, then 30. Okay, and similarly, let me complete the scale of frequency density upwards also. So I've done that up to 24 because 20.4 was the highest frequency density. So I've gone up to 24 with the scale which is uniform, 4 units with each part. All right. Now we have to draw these columns which are up to 5, 10, 20, 30 and 50. All right. Our first column will be at 5. 1, 2, 3, 4, 5 here. Second at 10, third at 20, fourth at 30, and then we have 50. Okay. Now let's see what will be the height. Height will be the frequency density. 4.6, 20.4, 13.5. So one will be 0.4. So 0.6 will be one column above this. So we have to draw up to here, 4.6. 20.4 is the next one. Okay. So it will be one unit above 20 here. Next, 13.5, then 7.6. So this is the histogram with frequency density. We have drawn it. Let's go to the next part of this. Calculate an estimate of the mean. Estimate means it will not be accurate, but yeah, it is should be close enough. Time taken by an employee to travel to work. So frequency density will not be used here. So what will we do? We will write the class first. So it was 0 to 5, then 5 to 10, then 10 to 20, 20 to 30, and 30 to 50. For mean, we need midpoint of the data. Midpoint will be add these two and divide by 2, which will be 2.5. 0 plus 5 divided by 2, 2.5, 7.5, 15, 25, and 40. Now we write the frequency, which is 23, 102, 135, 76, and 24. Okay, this is frequency. So to find mean, we will write sigma xf over sigma f. Sigma f has been given to us. How many were they? They were 360. So total of the frequency is 360. They have already given us. So sigma f is known to us. 360. The only thing left is sigma xf. So first we have to multiply x and f. What is x? X is nothing but the midpoint. So we multiply 2.5 and 23, we get here xf. So let me do that here, 75. The sum comes out to be 5707.5. That we will write here. And if we divide this, we get mean equal to 15.9 minutes. Let's move on to the next one, which is this. Raj wants to improve his fitness. So every day he goes for a run. The time in minutes he runs have a normal distribution. Okay. The mean is 41.2 minutes. Okay. Standard deviation is 3.6. Find the probability that on a randomly chosen day, Raj runs for more than 43.2. So 43.2, suppose 43.2 is here. So we want this probability when he runs for more than 43.2. So we should know first of all the Z score for 43.2 and less. This dotted area we'll find and we'll subtract that probability from 1. First we'll find the Z score. So Z will be 43.2 minus 41.2 and divided by 3.6, which is 2 divided by 3.6, comes out to be 0.5556, we can write, right? And let's use our normal distribution table to find the probability for 0.556. 0.55 is 0.7088, and then we have 6, which is 20 in the same line. So that comes out as 0.7108. 0.7108, and this is what we will use here. So probability that x is less than 43.2 is 0.7108, and probability that x is greater than 43.2, we can use it equal here, 43.2. It doesn't matter in continuous data whether you write equal here or there, but the language they have written is Raj runs for more than, not equal to, more than. So that's why I wrote equal here. 1 minus 0.7108, and that will be 0.2892, and three significant figures will be 0.289. Okay, what is next? Find an estimate number of days in a year, 365 days, on which Raj runs for less than 43.2. Less than, earlier was more than, if you remember. It was more than, that's why we subtracted from 1. Now it is less than. So we know that the expected, estimated value, that means they're saying expected value is NP. N is 365 days. Probability is, we got 0.7108, and if we multiply this, we get 259.4 days, and 0.4 days is not accurate. We can make it either 259 or 260 days. 259 is closer, so we'll write 259 days. Next, on 95% of the days, Raj runs more than t minutes. Alright, 95% is a very big probability. So if I draw it again, 95% will be somewhere like this. This will be 95%, the more one. But there is no Z score I can find for this part. So what will I do? I will reflect it here, and I will find Z score for this, the reflection. Under that, there will be 95% probability, okay, 0.95. So, and once I get that Z score, I will make a negative Z score of that, and I'll get Z score for this, and then I can find it very easily. So, let me find the Z score for this bigger one. Let's call it T prime, and let's find Z score for this, under which 95% of the data is there. That means from probability, we have to find Z score. So probability is 0.95. So 0.95 is here, 9495. Okay, it is 1.6, and if we show there 4, we need 5 more. So 5. So 1.6 4, 5. That is the z-score of this t prime. But we wanted this one. It will become minus 1.645, and that's what we will use. So t was the data minus the average is 41.2 divided by so t minus 41.2 equal to negative 1.645 times 3.6, and t will be negative 1.645 times 3.6. Let's make it separate and add 41.2 to this because this will come to the right side. And if we use our calculator, let's see what it gives us. We get 35.278. In three significant figures, it will be 35.3. A security code consists of 2 letters followed by 4 numbers. So we have letters, and then 1, 2, 3, 4. Number, 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 and number. That means we can't write letters later and numbers first. Their places are fixed. The letters are chosen from A, B, C, D, E, 5 of them, okay? And digits are chosen from these 7 numbers. No letter or digit may appear more than once. An example is this. How many different codes can be formed? The total number of possibilities. So we have to select 2 letters for these places, and total we have 5. And the order of the letters is important, that's why we'll use P, permutation. And then we multiply by 7 permutation, how many? 4, which is equal to 16,800 permutations. Next is this. Find the number of different codes that include letter A or digit 5 or both. So there are 3 possibilities. When letter A is there but digit 5 is not there. Digit 5 is there but letter A is not there. And then we have 5 and A both are together. They are present. Let's focus on this one first. First 2 places are to be filled with letters. One of the place has been taken by A. So we are left with only one. But A can take the first or second. There are different cases, right? So it can take 2 ways. So we will multiply the whole combinations by 2. Remaining is one place which is to be filled by remaining 4 letters. There are total 5 letters. A is already here. So 4 out of 4, we have to select 1. We are in P because positioning is important, though 4P1 and 4C1 are exactly same, but still. Let's talk about the remaining 4 places. Here we can't select 5 because 5 is out of the race, and we have 7 numbers from which we have to select 4. But 5 has been already excluded, so we left with 6 numbers out of which we have to select 4. This is the first case. Second, 1, 2. A cannot be chosen. That means for these 2 places we need 2 letters from remaining 4. So it will be 4P2 multiplied by 1, 2, 3, 4 places for digit 5. Again, 5 can take any of the 4 digits, 4 places rather. So 4 for 5. Now remaining 3 places will be left once 4 has taken one of the places. And we have to select those places from 6 numbers because 5 is already here. So 6 are left, and out of those 6 we have to fill up 3 remaining spaces. This will be the second case. Third, 1, 2. Again, same letter A is here. It can take any of the 2 places. So 2 multiplied by, and we have to fill up the second space by any of the remaining 4. So 4P1. Now 1, 2, 3, 4. 5 has taken one of these 4 places. Which one? We don't know. I've written 5 here, but it can take any of the 4. So we write 4. And we have to fill up the remaining 3 places from the remaining 6 numbers. So I will evaluate them one by one and add them, because one of these 3 situations will happen, not all of them together. So when we have this or this or this, then we add the permutations we get. So when I use my calculator, I get 2880 for the first combination, 5760 for second combination, 3840 for third, and if I add all of them, I get 12480. Let's move on to the next part. A security code is formed at random. Find the probability that the code DE, so first 2 letters are DE, followed by a number between 4500 and 5000. 1, 2, 3, 4 digit has to be needed. And between them, that means the first digit is 4 confirmed, isn't it? Because less than 5000 is not included. Between means 5000 is not included. So highest we can have is 4999, but we can't repeat any number also. So first digit is 4, that is for sure. We have to just look at these 3. So what are the options available with us? Let's see. 1, 2, 3, 4, 5, 6, 7. Okay. Since numbers cannot repeat, 4 cannot repeat. So we are left with 1, 2, 3, 5, 6, 7. Now it has to be more than 4500. That means this digit could be 5 or 6 or 7. We can't write 1, 2, 3 here. That will make it less than 4500. So there are 3 possibilities for this, and 4 was 1 here. Please don't write 4 as a multiple here. Only one possibility is here, which is 4. So I'm writing 4 down, but it is one number. And 3 possibilities for the second number, and other are any number we can use in the rest of the 2, but out of these 7. 4 has taken 1 place, 1 has taken this place, so how many are left out of 6? So remaining are just 5 now. So 5 will be here, 4 will be here. So total number possible are 3 times 5 times 4, 60 codes are possible. And total number were possible, how many? 16,800. So probability of this one, probability will be equal to 60 out of 16,800, which is 1 out of 280. This is the probability. Question number 6. In a game, Jim throws 3 darts on a board. It's called a turn. The center of the board is called bullseye. The random variable x is a variable of darts in turn that hit the bullseye. Okay. The probability distribution of x is given in the following table. So there are 3 turns, right? 3 times. So maximum you can get 3 bullseye. You cannot get 1 bullseye, that is 0. So they have given the probability of all in this probability distribution, but p and q are the variable for 1 and 2 respectively. It is given that expected value of x is 0.55, that will be the score. Find the value of p and q. Okay, so there are p and q, 2 variables, we need 2 equations. So let me separate them. The first fact we should know that the sum of all the probabilities of a probability distribution is 1. That means if I add probability 0.6 plus p plus q plus 0.05, it will be equal to 1, and that gives us one equation. P plus q equal to 0.6 plus 0.05 will be 0.65, so, and that goes to the right side, becomes negative. So P plus Q is 0.35. This is our equation number 1. Second equation, they have given that the expected value is 0.55, and expected value Ex is sigma x p. X is the variable x and p is the probability of x. We multiply them and individually first, and then we add all of them. That sigma means. So it means 0.6 will multiply with 0 because it's the probability of 0. Then P will multiply with 1, then Q multiplies with 2, and then 0.05 multiplies with 3, and that gives us 0.55. This becomes our second equation. Let's simplify this first. 0, it goes away. P times 1 is P plus 2Q, and 0.05 times 3 will be 0.15. That I will take to the right side. 0.55 was already here, and 0.15 goes there. P plus 2Q equal to 0.4. And now we can substitute one into other, or let's eliminate. So I will write this one under this. P plus Q equal to 0.35. I write under the second equation and subtract, so that P is eliminated. And 2Q minus Q is just Q. And 0.4 minus 0.35 will be 0.05. So we got Q. What about P? We can do it here. P will be 0.35 minus Q, right? From this we can get that, and Q is known to us now. P will be 0.35 minus 0.05, which is 0.3. This is P. We got P and Q both. Okay, what's the next one? Find the variance of X. And formula for variance is given in the formula sheet you're supplied. It is V plus variance equal to sigma x square P minus square of expected value. So expected value is known to us, 0.55. So we will square that, substituted already. Now we will square every x and multiply with its probability. So let's see, we can need some space. So let's see here, x squared, so 0 square, and the probability of 0 is 0.6. Then 1 square, probability is p is 0.3, we just got it. Then 2 square, probability is q, which was 0.05. And then probability of 3 was 0.05 again. Just do this and subtract, we will get our variance. So this is 0. 1 square times 0.3 will be 0.3. 4 times 0.05 will be 0.2. 9 times 0.05 will be 0.45, minus square of 0.55 will be 0.3025. 0.3 plus 0.2 plus 0.45 is 0.95 minus 0.3025, which will be 0.6475. Let's move on to the next part of the same question, which is this. Jim is practicing for a competition and he repeatedly throws 3 darts on the board, means he takes turn. Find the probability that x equal to 1 is at least 3 of the 12 randomly chosen turns. Since 12 randomly chosen turns makes it fixed number of attempts, we will use binomial distribution. Okay, probability remains unchanged, every turn is independent, so good. This becomes our binomial distribution. For that binomial distribution, we know n is 12. What is the probability of success? So x equal to 1 is the success. If he hits the bullseye once is success, the probability is p, and the p was 0.3. So 0.3 becomes the success, probability of success. That means probability of failure will be 1 minus 0.3, which is 0.7. We want at least 3. At least 3. What does it mean? It means 3 or 4 or 5 or 6 till 12. Right? That is at least 3, which is a long list. So what will I do instead? I will do it. So probability that y, let's call it y, not x, we can't use the word x, y is at least 3, that means it is 3 or more, will be equal to 1 minus probability of 0, let's write here like this, and or probability of 1 or probability of 2, because in the whole list 0, 1, 2 are excluded, the rest everything is there, 3, 4, 5, 6, 7, everyone is there. So I will find the probability of these three and subtract from 1, I will get this long list. So let's interpret them into binomial distribution. So 1 minus I'll take care later, P0 first of all. P0 will be 12 is the total number of attempts. We don't want any success. Success probability is 0.3 and failures is 0.7. So all 12 are failure in different positions of attempts. P1 will be 12C1 0.3 to the power 1, 0.7 to the power 11 this time, because 11 plus 1, 12, that makes it 11 failures and 1 success. P of 2 will be 12C2 0.32 and 0.3, gets it right, 10. So now we will evaluate these three, add them and subtract from 1. By the time I do this, please subscribe to my channel and share, like this video, comment if you want some different kind of solutions also, and motivate me to make more videos for you. Thank you. And when I use my calculator, this one I get as 0.01384 and this one 0.07118, 0.16779, and if I add these three, I get 0.25781 or 281. Alright, so finally we have to subtract this from 1. 25281, which comes out to be 0.74719, which we have to round off to 3 significant figures, 0.747. This is the probability. What's next? Find the probability that Jim first succeeds in hitting his bull's eye with all 3 darts on his 9th turn. All 3 darts. That means he is successful in hitting all 3. What was the probability of hitting all 3? So all 3 was 0.05. That was the success probability. So probability of success is 0.05. Then failure will be 1 minus 0.05, which is 0.95. So now he is successful on 9th turn. That means 8 turns he does not get all 3. He fails to get all 3 bullseye. So he fails for 8 attempts, but he is successful in the 9th attempt, and that makes it geometric distribution. Fail, 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 and finally succeed on the 9th attempt. And if we put this in a calculator, that becomes 0.0332. Let's move on to the next one. Quite a detailed one. Question number 7. Box A contains 6 red balls and 4 blue balls. Okay. Box B contains X red balls and 9 blue balls. A ball is chosen at random from box A and placed in box B. Okay, so box B will have more balls than original ones. Okay, a ball is then chosen at random from box B. Complete the tree diagram below, giving remaining 4 probabilities in terms of X. So that means twice the balls are being removed, once from box A, once from box B. So let's, they have written here already the probability 6 over 10 and 4 over 10 for the first ball. First box A. Now the box B has how many balls now? X red balls and 9 blue balls plus 1, which has been drawn first. In this branch, red was drawn first. So now the red balls are x plus 1. Let me write here. X plus 1 are the red balls. And then we have 9 blue balls. That makes it x plus 10. Total balls are x plus 10. Okay. So what is the probability that he will draw a red ball from the first box? So it will be total number of red balls. Total number of red balls are x plus 1 divided by total number of balls, which are x plus 10. Right? Next, what is the probability that a blue ball will be drawn? So how many blue balls are there? 9. Out of how many total balls? X plus 10. Similarly, in this branch, blue ball was drawn and put into the box B. So number of red balls will remain x, but total balls are x plus 10 again. Next, the probability of blue ball, because the previous ball was blue and its number have increased, so it will be 10 now out of x plus 10. This is the completion of the tree diagram. Next part, show that the probability that both balls are chosen are blue is 4 over x plus 10. So blue is here, blue is here. This branch we will look at and multiply the probabilities. First probability is 4 over 10, first blue ball. Second blue ball is 10 over x over 10, x plus 10 rather. So 10 and 10 cancel out. We are left with 4 over x plus 10. That's what they wanted. Bring it on the next one, please. Next one is, it is given that the probability that both balls chosen are blue is 1 over 6. So both balls chosen are blue is 4 over x plus 10. It is 1 over 6. Let's find x with the help of this. Let's not read the C part. 4 over x plus 10 equal to 1 over 6 cross multiply 24 equal to x plus 10, 24 minus 10 equal to x. So x becomes 14. So x is not unknown anymore. Let's read the question. Find the probability correct to 3 significant figures. Probability that the ball chosen from box A is red, given that the ball chosen from box B is also red. Okay, so probability that ball chosen from box A is red. So red in A ball, given that we got red from box B. So we have a formula which is probability of A given B is probability A intersection B divided by probability of B. So if we interpret the same thing in this situation, it will be RA, red from box A, intersection red from box B, divided by probability that we get a red ball from box B. We get red balls from box B is these two cases, right? And they are 6 over 10 and this. This is the first probability of getting red ball because we need this one. So probability that we get a red ball from box B is, what was the probability? 4 over 10. First one was 4 over 10, no 6 over 10. 6 over 10 was this one and it was x plus 1, x over 10. So 6 over 10 multiplied by x plus 10, which is 14 plus 1 over 14 plus 10. That was the one. Alright, or you get first ball as blue, 4 over 10, and the probability of a red in second attempt, second B, box B, is this one. So 4 over 10 multiplied by x over x plus 10. So 14 over 14 plus 10. These are the two separate cases when the ball from the box B is red. And let's try to simplify this, and we will substitute that here. 6 over 10 multiplied by 15 over 24. 6 cancels this. 10 is 5 times 2, 5 times 3. Plus 4 over 10 times 14 over 24. Again, this cancels here. And here is 7 and 5. So what do we get here? We get 3 over 8 here, plus we get 7 over 30. This will be our denominator, because this is what it is. Probability that the ball from the box B is red. Alright. Now we have to look for the branch where it was red ball from box A as well as box B. So box A is 6 over 10 multiplied by this that we have already got, which is 3 over 8. So our final solution becomes probability that the red ball from A, given that the red ball from B is 3 over 8, which is A intersection B in the case of this thing, and 3 over 8 plus 7 over 30. 0.61644, we can write, but we need 3 significant figures. It will be 0.616.